Dear learners, we have learnt about electrochemical cells in our previous discussions. Today, we are going to discuss some interesting applications of electrochemical cells. In today's discussion, you will be able to describe the construction and working of some primary and secondary batteries and fuel cells. You will also be able to explain corrosion as an electrochemical process. The electrochemical cells are the source of electrical energy and can be used as commercial cells. In order to use electrochemical cell commercially, it needs to fulfill two requirements. It should be compact and portable, and the voltage drop in the cell when put to use must be steady. When several electrochemical cells are combined and connected in series, it forms a battery. Though the function of battery is almost similar to the galvanic cell, a battery is still better in application than galvanic cell, as it does not require a salt bridge and thus is compact. Batteries are classified into three types: primary cells, secondary cells, and fuel cells. Primary cells are considered as those electrochemical cells which once discharged or used cannot be recharged. Or we may say that the electrochemical reaction cannot be reversed by passing the electricity through the cell. That's why a primary cell becomes dead after being used for some time. The most commonly used primary cell is a dry cell. This was invented by the scientist G. Leclanche in 1868 and thus also known as Leclanche cell. Let us dissect a dry cell and find out what is present inside. This is a dry cell. On dissecting this dry cell, we have to remove the covering of the cell, and inside it consists of a cylindrical vessel made of zinc and is filled with a paste of ammonium chloride to which a little zinc chloride is added. The zinc cylinder acts as the anode, while the carbon rod present inside acts as the cathode. The cathode is surrounded by a black paste of manganese dioxide, which you can see in this dry cell. When the cell is working, zinc loses electrons to give zinc ions. The electrons pass around the external circuit and are taken up at the cathode. This causes discharge of ammonium ions. The reactions taking place at the electrodes can be represented as: at anode, zinc undergoes oxidation to form zinc ions, while at cathode, ammonium ions mixes up with manganese oxide and undergoes reduction to form manganese oxide, ammonia and water. So the overall reaction becomes zinc plus ammonium ions plus manganese oxide, giving zinc ions plus manganese oxide plus ammonia and water. During its working, the zinc container is slowly consumed, and even the cell is working, the acidic ammonium chloride corrodes the zinc container. Thus, we may find several holes leading to the leakage of the container. To avoid this, zinc container is covered with a thin sheet of another metal which is inert in nature. Such cells are known as leak-proof cells. A dry cell generates a steady voltage between 1.25 volt to 1.5 volt. You can also improvise your own dry cell. For this, you need a zinc plate, a carbon rod, a manganese dioxide powder, ammonium chloride solution, cotton pad and copper wires. For the feasibility of the demonstration, we have prepared a setup for you all already. For this, we have dipped the cotton pad in saturated solution of ammonium chloride and spread over the zinc plate. The manganese dioxide is sprinkled over this pad and the carbon rod is wrapped around this pad. As soon as we connect the wires to the clock, do you observe anything? The needle of the clock starts moving. And yes, your dry cell is ready. After having hands-on experience, do you still think that the cell is dry? Actually, the word dry here is a misnomer, because from our previous discussions, we understand that the electrolyte should be in molten or in the aqueous phase. Had this been dry, it would have never worked like it does. Let us talk about another example of primary cell, which you must have seen in hearing aids and watches. These are called mercury cells. It consists of zinc-mercury amalgam as anode and a paste of mercury oxide and carbon as the cathode. The electrolyte is a paste of potassium hydroxide and zinc oxide. The electrode reaction for the cell are: at anode, zinc reacts with hydroxide ions to give zinc oxide and water with the loss of 2 electrons, while at cathode, mercury oxide reacts with water and gains the electrons to form mercury with hydroxyl ions. Overall reaction involves zinc amalgam reacting with mercury oxide to form zinc oxide and mercury. The cell potential is approximately 1.35 volt and remains constant during its life, as the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. Another type of batteries are the secondary cells. These are the cells which can be recharged on passing electric current. These are also known as storage cell or accumulators, as they store electrical energy within them. Lead storage battery is the commonly used secondary cell. This is constructed by combining 3 or 6 cells of 2 volt to get a 6 volt or a 12 volt battery. The anode consists of a number of plates connected in parallel. Each plate is a grid of lead filled with finely divided spongy lead. Similarly, cathode also consists of an equal number of plates connected in parallel. Each plate in this case is a grid of lead packed with lead oxide. The whole arrangement is suspended in dilute sulfuric acid, which is 38% sulfuric acid by mass. Dilute sulfuric acid acts as electrolyte. So at anode, lead reacts with sulfate ions to form lead sulfate with the loss of 2 electrons. At cathode, lead oxide reacts with hydrogen ions and sulfate ions with the gain of 2 electrons to form lead sulfate and water. So the overall reaction becomes lead plus PbO2, that is lead oxide, in the presence of hydrogen ions and sulfate ions, giving lead sulfate and water. Sulfuric acid is consumed during the discharging of the cell. On recharging the cell operates like an electrolytic cell, and electrode reactions get reversed. Another important secondary cell is the nickel-cadmium cell, which has longer life than the lead storage cell, but more expensive to manufacture. The overall reaction during the discharge of the cell is cadmium reacting with nickel hydroxide to form cadmium oxide, nickel hydroxide and water. The secondary cells have some advantages over primary cells. Secondary cells can be recharged by passing direct current from external source. Primary cells cannot be recharged. Primary cells last for short time duration, while secondary cell can undergo a large number of charging and discharging cycles. The third category of batteries is fuel cell, which is a device to convert the chemical energy of a fuel directly into electrical energy. Such conversions are possible because of the redox reactions taking place during combustion of fuel. Hydrogen-oxygen fuel cell is one such fuel cell commonly used. The cell consists of 3 compartments separated by electrodes which are made up of porous carbon. Catalysts like platinum or palladium are incorporated in the pores of electrodes in order to accelerate the chemical reactions that are taking place. The central compartment contains aqueous sodium hydroxide or potassium hydroxide, which acts as the electrolyte. Gaseous hydrogen and oxygen are bubbled through the pores of the catalyst. The reactions are given as at anode, hydrogen reacts with hydroxyl ions to form water with the loss of 4 electrons, while at cathode, oxygen reacts with water and gain the 4 electrons to form hydroxyl ions. And so, the overall reaction becomes hydrogen adding up with oxygen to form water. Electricity is generated as a result of the redox reaction. The cell can work continuously as long as the fuels, hydrogen and oxygen are available. The fuel cell is basically a type of electrochemical cell which has several advantages. A fuel cell can work continuously as long as the fuels are supplied at the electrodes. Fuel cell is considered eco-friendly as it does not cause any pollution problem. Fuel cells also have efficiency of almost 60 to 70%, which is considered as a high efficiency. In spite of all the advantages, fuel cells have disadvantages too. The catalysts like platinum or palladium are very expensive. The gaseous fuels like hydrogen and oxygen are difficult to be stored. The electrolytes sodium hydroxide or potassium hydroxide are corrosive in nature. So till now we have learnt an application of electrochemistry in the form of batteries. But there is one more application of electrochemistry which is observed in daily life. When metals are exposed to air or kept in open for some days, their surfaces are eaten up. This happens because metals get converted to various forms like oxides, carbonates or sulfides. Once the metals come in contact with the gases and water vapors present in the air. Corrosion is defined as the process of slow eating up of a metal by the gases and water vapors present in air due to the formation of certain chemical compounds. If iron is the metal, the chemical process is known as rusting because of formation of rust, which is hydrated ferric oxide and is given by the formula Fe2O3.XH2O. The rusting of iron, tarnishing of silver, development of green coating on copper and bronze are some of the examples of corrosion. Let us understand the mechanism of corrosion with the help of rusting of iron. At a particular spot of an object made of iron, oxidation takes place and that spot behaves as anode. And we can write the reaction as iron getting oxidized to ferrous ions with the loss of 2 electrons. Electrons released at anodic spot move through the metal and go to another spot on the metal and reduce oxygen in the presence of hydrogen ions. This spot behaves as cathode with the reaction when oxygen reacts with hydrogen ion and gains electron to form water. Thus, the net reaction taking place becomes iron reacting with oxygen in the presence of hydrogen ions to form ferrous ions and water molecules. These ferrous ions are oxidized by atmospheric oxygen to ferric ions, which combine with molecules of water to form hydrated ferric oxide Fe2O3 which is called rust. Corrosion causes enormous damage to our economy. We lose crores of rupees every year on account of corrosion. Therefore, there is a need to find a way to prevent corrosion. There are a number of ways to prevent corrosion, and some of them are being discussed here. One is barrier protection. As the name suggests, it creates a hindrance or the barrier between the metal surface and atmospheric moist air. This hindrance can be created by keeping the surface of the metal smooth, by painting the surface of the metal, by coating the metal surface with a thin film of oil or grease, or by coating iron with some non-corroding metal such as copper, nickel, chromium or aluminium. Second method is sacrificial protection. In this method, the surface of the metal to be protected is coated with a more reactive metal. That is, a metal which occupies a position lower in the electrochemical series than the metal to be protected. Iron is generally coated with zinc in order to prevent it from corrosion, and this process is called galvanization. Another method is electrical protection. This method is also known as cathodic protection. It is another type of sacrificial protection method which is specifically used for the protection of submerged structures, ships and underground pipes. In this method, the exposed surface of iron is protected by connecting it to some more active metal such as magnesium, zinc or aluminium. The more active metal acts as anode and loses electrons in preference to the iron which acts as a cathode. And another method is to use anti-rust solution. The alkaline solutions of some phosphate or chromate salts act as anti-rust solutions. These solutions prevent the availability of hydrogen ions which facilitate the oxidation of iron to ferrous ions. So to summarize today's discussion, we understood the construction and working of primary cells. We learnt a method to create our own dry cell. We also understood the construction and working of secondary cells. A primary cell cannot be recharged, but a secondary cell can be recharged. A fuel cell is a device which converts chemical energy of a fuel directly into electrical energy. Fuel cells are better than both primary and secondary cells and can work as long as the supply of fuel is maintained. Corrosion is the process of slow eating up of a metal by the gases and water vapors present in air due to the formation of certain chemical substances. Coating of iron with zinc in order to prevent it from corrosion is called galvanization, while the coating of iron with tin is called tinning. For the assignment, let us learn to do some research work today. Since fuel cells are being researched and produced on a very large scale, I request you all to investigate the types of fuel cells that can be brought into use and how can we increase their efficiency for a better future. For this, you may use a literature survey to get an idea. I hope you understood all the concepts discussed in today's discussion. That's all for today. Have a nice day.